Great. First of all, thanks, Maria, Ayman, for inviting me to participate in this session. It's an honor for me to be here. My presentation is going to be a little bit different from the previous one. The main reason is because there is no, or there are no FRP codes specific, codes specific to FRP in Latin America, with the exception of Brazil, which Dr. Cardoso just showed us. So I'm going to give a different description. The intent of this presentation is to provide a description, provide an overview of how FRP strengthening, how it's used or how it's implemented in Latin America, many countries in Latin America, in the context of the codes. Specifically, how the engineers in the region use existing codes, primarily ACI and European codes. So my intent is not to give you a class of geography, but you all know what entails Latin America, obviously with Brazil there. We cannot forget Brazil, five times world champion, so we can never forget that. The best player, Pelé, better than Maradona, that's what they said. So when I was asked by Maria and Ayman to give a talk on this topic, it was kind of challenging because, as you see, there are different countries in Latin America which have many things in common. Primarily, the one thing is the language, the Spanish language, with the exception of Brazil and other countries. So, but at the same time, the engineering and construction practices are not probably the same. So, one thing that I did is I reached out to engineers in different countries, which you can see here. Each star represents a country where I was able to talk to some engineers. I started in Mexico, continued in Costa Rica, Panama, Venezuela, Colombia, Quito, Peru, Chile, and Argentina. I didn't talk to people in Brazil because obviously Dr. Cardoso was going to cover that. So I am originally from Peru, which is on the west side of South America. So what I did is I reached out to 39, or close to 40, 35, 36 engineers in Latin America, and from different countries, as you can see here. And we had like 30-minute to 1 hour meetings in the last 2 months, I guess. So I was spending some of my afternoons and weekends talking to some engineers. So basically I came up with my own ACI 440 at this point, right? So I want to acknowledge their contribution because each of them gave me good input. Even within same countries like in Colombia, I got different input from different engineers depending on their practice. In Mexico, very important, depending on where you're in Mexico, if you're close to the capital, Mexico City, you have other needs compared to other places like Monterrey, which is in the north of Mexico. So I want to acknowledge their contribution because without their contribution it would be, for me, impossible to be here. So we set up this meeting agenda for each so we can keep it organized. We discussed about the typical FRP applications in their countries, what are the common FRP systems, what they use for design, and when they need to design or use FRP, what they see for barriers for further use of FRP, and based on that we came up with needs and opportunities for increased acceptance of the material. So typical FRP applications, the first FRP applications in Latin America date back to the late 1990s, from what I know. I was told Venezuela was one of the first countries that basically used FRP for the strengthening of existing concretes. Mainly, it's on strengthening of existing structures, no new construction. is used for building structures, bridges, and non-building structures like tanks, pipes. The use of FRP in Latin America is no different to what you see in different parts of the world. It's the same applications. It's primarily used in concrete structures, some masonry structures, not a lot, compared to, which was kind of revealing to me, given that there's a lot of masonry construction in Latin America, but it's not used a lot for strengthening. And one material that is gaining traction is FRCM, specifically for masonry. There is no experience in the use of FRP bars in new concrete construction, although people know that the material exists, that there are codes that can be used as FRP reinforced concrete elements. They see a lot of potential in the region, specifically in marine construction. So this shows the common FRP systems used in Latin America, primarily FRP weight layup systems, with some FRP precure systems to a lesser extent. And this is primarily based on availability. It's what the manufacturers provide to people, to engineers there. CFRP is a preferred system. Some GFRP systems applications, again, GFRP is not readily available, so people use what they have. In general, there is no applications with FRP bars, so there is no strengthening with NSM bars. Needless to say, new constructions, because there are FRP bars are not readily available. Regarding design practices, designs are mostly based on ACI 440 guidelines. Maria showed us in the first presentation that there are recent codes for or standards or guides, I'm sorry, for ACI for concrete strengthening and masonry strengthening. These are the previous one. The ACI 442R, the previous one, is well-known guide. Everybody knows that guide. ACI 442R is known by some, which was kind of disappointing for me being the chair of the committee. And coming from that region, it was a double disappointment. But it's not well known because they don't use it. They don't need it. Typically, the engineers follow these design guides or use programs. This is very important. Programs prepared and distributed by FRP manufacturers. So in some cases, the design is delegated to the FRP manufacturers, which creates some issues. So some of the FRP manufacturers act as engineers, and the engineers include in their calculation package the output of the FRP program, really. So it's a risk, but that's a risk that they are taking. The programs include options, typically. An option to select ACI 440 procedures or European guides. And I'm going to describe what happens. ACI 442R is also used for the strengthening of bridges. People are not aware of the availability of ASHTO guides, which is good for ACI, I guess, but not good for ASHTO. That not necessarily is true, but I guess people don't know about the availability of ASHTO. They use ACI 442R for strengthening of bridges. Regarding design practices, there is some use of European guides. When this happens, typically when the procedures are not covered by ACI 440, which are a lot, like specific and seismic procedures. And also when the design is more favorable, right? When there is less reinforcement, especially when they are competing against other engineers or other contractors, it's a design build, and that happens in the US too, with some, and the thing here in the US is that they are using ACI 440 the same way, but somehow some get less reinforcement. That's a different story. But in Latin America, many use European codes when it's more favorable. Again, the manufacturers' programs include options to select 440 or European code, but this creates a compatibility issues with codes because the majority of the reinforced concrete codes, when you calculate the loads, are similar to what you have here in terms of AAC 7, if you're not familiar, or ACI 318. So you calculate the demand the same way, right? So if you do that, the capacity has to be calculated the same way, following the same approach. So some people they have identified mistakes when they calculate the factor loads using ACI or similar to ACI by calculating the strength using European codes. So there's a compatibility issue. And these are some of the codes that they use, some were previously presented here. What are the barriers for further use? I think Dr. Cardoso alluded to some of these. Practicing engineers' lack of knowledge of FRP composite materials. When I say practicing, is people who don't really use it every time, but they see the opportunities through their practice. They don't understand the advantages and limitations. They don't know the design methodologies. So if you don't know it, you don't specify it. That happens in the United States too. We've seen that. There is some mistrust due to misuse. They have seen wrong applications on the material pushed beyond the limits by some engineers and manufacturers. There's issues too with the mixing of components. They get the fibers from manufacturer A and the resin from manufacturer B. That's no good. But they have seen some issues. There is no availability of FRP system in local markets. The weight layup and the procure systems are readily available, but there is no availability of bars. There is also higher cost perception compared to other strengthening methods like section enlargement. And some barriers just to finalize for local building codes. In general, as I said, there is no specific reference to FRP. So if there is no specific reference to FRP, it's allowed. With some exceptions. It's not allowed in Colombia for seismic applications. It's kind of a conservative approach. However, in Mexico City, which is a city which a lot of seismic issues, is allowed and is included in the Mexico City's building code. And the Mexico City's building code that you see here makes reference to ACI 442. Sorry, to finalize, and this is the main takeaways. Where are the needs and opportunities for increased acceptance? And this is a labor, a work, a joint effort from universities, professional organizations, and engineers. Where are the needs? First, need to educate the stakeholders. And this happens in the United States here. I practice here, and I see the same thing, right? So it's not different to what you see here. You need to educate the stakeholders at 3 levels. Owners, because the owners are responsible for initiating the projects. It's a high-level education. They need to understand the limitations. They need to understand there's a material that can help them, but how far they can go. They have to manage. We need to manage their expectations. There is no magic capabilities. The practitioners, designers and building officials, understand advantages and limitations, learn how to design, how to specify, and take ownership of the design. Less delegation. We see it here too. They delegate it to manufacturers or to other engineers. And the students, which are the future of our profession, learn how to design and specify FRP. The universities need to start offering FRP-related courses at undergrad and grad level. For manufacturers, who are responsible for promoting and selling material, offer more FRP systems. In addition to the weight layup systems, provide FRP bars too in the market. And also educate their sales force to understand proper use of FRP. Many times manufacturers have to sell it, understandably, but too aggressive. That's how they see it over there. No, I'm not saying in the United States. And finally, this is very important for our committee. They feel that there is a need for guides or codes in Spanish, because that will promote the use of the material. If you understand, it is written in your language, you will understand it better. There's opportunities for organizations, and I'm just saying ACI, could be others, to partner with local professional organizations to translate codes which can be adopted or adapted by local building codes. They use the word tropicalize the documents because they can be adjusted. Offer courses and webinars in Spanish. They see a lot of courses, but they see ACI, for instance, as an unbiased provider. So they would like to see that. And finally, to just give an example of where these webinars are going, now ACI 440, some members of ACI 440 are going to be traveling to Colombia in a month. I'll be there, Maria will be there, and others. And we're going to be presenting on the latest ACI 440 guides on trends and codes in design, for design and construction of the FRP. Thank you.